Hey guys, I'm back with the orthorhombic system normal class. This is the third system of the orthogonal system group, which comprises of isometric, tetragonal, and orthorhombic systems. Let us have a look at it. So, in the orthorhombic system, as I previously mentioned, none of the axes are equal in size, but they all are placed perpendicularly to each other. So we have the notation A is not equal to B is not equal to C, but alpha, beta and gamma are equal to each other and they all are 90 degrees. We'll have a look at its axis in a moment. The normal class of orthorhombic system, it is also referred to as Barite class. So if you happen to get a question like this, which of the uh, crystal systems has Barite class as its normal class, it has to be orthorhombic system. All right, it has three forms: pinacoid, prism, and bipyramid. So we'll have a look at it one by one. In the orthorhombic system, the three crystallographic axes, that is A, B, and C, as we saw, are unequal to each other. Now it means that some of the axes would be longer and other would be shorter. So in orthorhombic system, the A axis is the shortest axis and therefore it has been named as brachyaxis. Brachy means short, while the B axis is the longer axis, it is known as macroaxis. While of course C is also not equal to any of these. So the shortest axis A is the brachyaxis while B is the macroaxis, and you can see here the angles between these axes, that angle between B axis and C axis, it is alpha. Angle between A axis and C axis is beta, while the angle between A axis and B axis is gamma. So all the three angles, they are equal to each other and they all are 90 degrees. This question has been asked several times in many of the competitive exams with MCQs about the brachy and macro axis. Alright. So the first form that we see in the normal class of orthorhombic system is the pinacoid form. It is of three types: basal pinacoid, macropinacoid, and brachypinacoid. Since the three axes are unequal to each other, they can be also named as C pinacoid, A pinacoid, and B pinacoid. Remember, in orthorhombic system there is a small trick to name the forms. If the pinacoid is intersecting the A axis, so pay attention here. If it is intersected by the A axis, which means A pinacoid, then it will be named with macro in its word. Now, if it is intersecting the B axis, which is the B pinacoid, it will be named with the word brachy. It is not like that if it is intersecting the macro axis, it becomes macropinacoid, and if it intersects brachy axis, it becomes brachypinacoid. So if we look at the uh, a diagram here, this diagram, we can see that the basal pinacoid, also known as the C pinacoid, it is intersecting the C axis at unit distance, so it runs parallel to A and B, so it becomes 0, 0, 1. In case of brachypinacoid, you remember, if it is brachypinacoid, it will intersect B axis, not A axis. It will be parallel to A axis. So in case of brachypinacoid, the symbol would be, the symbol would be 0, 1, 0, not 1, 0, 0. Sorry for that mistake. And in case of macropinacoid, the symbol becomes 1, 0, 0. Alright, so the brachypinacoid has its faces being intersected by the b-axis, so it becomes 0, 1, 0, while in the macropinacoid the faces are being intersected by the a-axis and it becomes 1, 0, 0. The a-axis is the brachyaxis while the b-axis is the macroaxis. So here we can see that the name brachypinacoid will be used for that form which is running parallel to the brachyaxis, okay, and intersecting the macroaxis, while the macropinacoid term will be used for the form where the faces are running parallel to the macroaxis and intersected by the brachyaxis. So the three pinacoids, they are perpendicular to each other, and as we all know, pinacoids are open forms. Next comes prism. In case of orthorhombic system, the prism is of three types: prism of third order, prism of second order, prism of first order. Prism of second order is also called as macrodome, and prism of first order is called as brachydome. If you will refer to old literature like that of Dana or Rutley's Elements of Mineralogy, old edition, then in that you will find the words specifically dome, macrodome, brachydome. They don't use the word prism of second order. This has been recently added, but I would rather suggest you to use the words dome rather than prism of second and first order for the other competitive examinations, because still in GSI and other exams if they ask macrodome, then you have to remember this word, otherwise you may get confused if you keep in mind the prism of second order. Okay, so we have three types of prism, macrodome, brachydome. All right, so let us have a look at this prism of third order, or simply prism. So if you remember, you know that prism is an open form with four faces. So in this case, if you recall what I told you in the tetragonal system, a proper definition of a prism is that the four faces that constitute this open form have to run parallel to the c-axis. That is the typical definition of a prism face. So here we can see that in the prism or the so-called prism of third order, the faces, they are running parallel to the c-axis and intersecting the a and b axis. So let us see, if let us say this is one of the faces, you can see here that this is b, this is a, and this is c. So since it is intersecting both the brachy and macro axis, we simply use the word prism here. The symbol will be HKO or 110. So as again I had mentioned previously, that a prism face will always be closed by a pinacoid face. Now it is the prism of third order or prism simply with a symbol of 110. So it will be closed by a basal pinacoid with a symbol of 001. Okay, now let us come to the prism of second order, so-called second order, or more specifically macrodome. Now remember, what is a dome and what is a dome? What is a dome face? So to define a dome face, you have to keep it in mind that it is also an open form with four faces, but here the c-axis will be intersecting and either of the two horizontal axes will run parallel. Means that it in this open form with four faces, the c-axis has to be intersected. Got it? All right. So very simple, that it is a an open form where the faces are parallel to the macro axis. The b axis, remember, is the macro axis, and since the face is running parallel to the macro, see this, if we simply open this, so this is one of the faces, this is the c axis, this is the A axis, and see, it is running parallel to the B axis. This is A and this is C. Now A axis is the brachy axis, B axis is the macro axis. None of the four faces will intersect the B-axis, and therefore, since they are running parallel to the macro axis, it will be called as macrodome. And so we have the Miller indices as, since intersecting A at unit distance, running parallel to B, and intersecting C at unit distance, the symbol becomes 1, 0, 1. So in that case, so this is another face. This is how you can draw. Okay, so we both can see that this face is intersected by C axis and A axis. If we draw it like this over here, so we close this we have to close this form now. So how it will be closed? It will be closed by this pinacoid, which is the B pinacoid. So it will be 0, 1, 0. So remember that the macrodome is an open form which is closed by a brachypinacoid. If you are getting confused, you can just see in this diagram that the macrodome is named so because it is running parallel to the macro axis, but since it is being closed by the pinacoid which is running parallel to A axis, so it becomes what? It becomes brachypinacoid. So we have a combination form of brachypinacoid and macrodome. Similarly, for brachydome, which is an open form, now how is brachydome defined? Brachydome is defined as an open form with four faces which is running parallel to A axis and intersects B and C axis. Okay, that is why the name brachydome. So for uh, closing the brachydome, you will have to use macropinacoid. I hope now it is all clear. So prism of third order, or simply prism, is 110 face. Then prism of second order or macrodome is 101 face, and prism of first order or typically brachydome is the 011 face. So all the three prisms are clear to everybody. You should try making these diagrams, and remember, once you get these concepts right, you will never end up making mistakes in the exams. Now we have a closed form. If you remember, in this you have seen this type of form previously also. So we saw this as octahedron in the isometric system, and of course bipyramid in the tetragonal system. It is again bipyramid in the orthorhombic system. Simple, it is uh, closed form with 8 faces. Since the axes are not equal to each other, the triangles will be all scalene triangles. None of the sides will be equal, and each face intersects all the three axes. So the Miller indices, they become HK and HKL, and since they are intersecting at unit distance, the symbol becomes 1 1 1. All right. So you can have several of these bipyramids occurring in combination with each other. Few examples of minerals which are crystallizing in the orthorhombic system, that is sulfur, tourmaline, barite, olivine. Okay, so I hope it is clear to everyone. Thank you. Have an awesome day.